As you settle into comfort and let your breathing slow, imagine drifting upward through Earth's atmosphere, past the clouds, beyond the blue sky, until you find yourself floating in the vast darkness of space. Here, in this infinite ocean of night, you're about to discover something extraordinary: galaxies, those magnificent islands of light scattered across the universe like luminous seeds drifting on cosmic winds. Our own home, the Milky Way, stretches above us like a river of stars. Ancient peoples saw this glowing band and imagined it was milk spilled across the heavens, hence its name. But what they were really seeing was something far more wondrous: our galaxy viewed from within, a spiral of hundreds of billions of stars wheeling slowly through space. And here's something beautifully humbling. We live about 2/3 of the way out from the galaxy's center, in a quiet stellar neighborhood on the edge of one of its spiral arms. We're cosmic suburbanites, residing in a peaceful corner where stars form at a gentle, measured pace. The Milky Way is not small. It takes light, traveling at 186,000 miles per second, about 100,000 years to cross from one edge to the other. Imagine that for a moment. Even moving at the speed of light, the fastest thing in the universe, you'd need 100,000 years just to traverse our single galaxy. And yet, despite this incomprehensible size, the Milky Way is just one galaxy among an estimated 2 trillion galaxies in the observable universe. 2 trillion islands of stars, each with their own story, each separated by vast oceans of space. As you float here in your imagination, consider this comforting truth: galaxies move through space at a stately, unhurried pace. Our Milky Way is actually on a slow collision course with our nearest large neighbor, the Andromeda Galaxy, but this meeting won't happen for another 4 billion years. 4 billion years. The universe operates on timescales so vast that even galactic collisions unfold like a gentle, slow-motion ballet. There's no rush in the cosmos, no urgency, just the patient, eternal dance of gravity and light. And perhaps most soothingly of all, when galaxies do eventually merge, they don't crash like solid objects. They're mostly empty space, with stars so far apart that they simply pass through one another like 2 clouds of fireflies drifting together on a summer night. The stars themselves rarely, if ever, collide. Instead, they find new orbits, new paths, creating something larger and more beautiful than what existed before. Let yourself rest in this knowledge as we continue our gentle journey through the galaxies. As your breath deepens and slows, let's drift closer to understanding these celestial islands. Galaxies, you see, come in the most peaceful, elegant shapes, forms that have existed for billions of years, slowly turning like cosmic meditation wheels in the darkness. Some galaxies are spirals, like our own Milky Way, with graceful arms that curl outward from a bright central core. These arms aren't rigid structures but gentle waves of density, places where stars and gas naturally gather over millions of years. Picture a pinwheel turning so slowly that a single rotation takes our galaxy approximately 225 million years. We call this a cosmic year, the time it takes our sun to complete one lazy orbit around the galactic center. In all of human history, in all the rise and fall of civilizations, we haven't even completed a fraction of one galactic rotation. The universe reminds us that not everything needs to move quickly. Then there are the elliptical galaxies, smooth, rounded collections of stars with no spiral arms at all. These are often the oldest galaxies, having long ago settled into a serene, spherical shape after the turbulence of their youth faded away. They're like ancient monasteries of the cosmos, filled with old, reddish stars that burn steadily and calmly, having exhausted the dramatic fire of their early years. In these galaxies, new stars rarely form. Instead, there's just the quiet glow of aged suns, humming their way through billions of years of peaceful existence. There's something wonderfully calming about the fact that between the stars of a galaxy lies mostly emptiness, vast distances of gentle darkness. If you could stand on a planet orbiting a star near the edge of a galaxy, the night sky might show only a handful of neighboring stars, with the rest of the galaxy appearing as a soft, distant glow. The space between is not harsh or violent, but simply quiet. A cosmic silence where particles of gas drift slowly through the void, occasionally gathering over eons to birth new stars. And here's a thought to carry you deeper into rest. Many galaxies exist in groups, gravitationally bound together like families. Our Milky Way belongs to what we call the local group, a collection of about 50 galaxies that drift through space together. The largest members of our group are the Milky Way, Andromeda, and the Triangulum Galaxy, while dozens of smaller dwarf galaxies orbit around them like children staying close to their parents. These dwarf galaxies are so faint and peaceful that many were only discovered in recent decades, having quietly existed in our cosmic neighborhood all along, patient and unhurried. Within these galactic families, members influence each other through gravity's gentle pull, not suddenly or violently, but through subtle tugs that play out over hundreds of millions of years. It's a reminder that even in the vastness of space, nothing exists in complete isolation. Everything is connected, everything influences everything else, but at a pace so gradual that patience becomes the fundamental virtue of the cosmos. Let your mind rest with these ancient, wheeling islands of light as we drift onward. As you sink deeper into tranquility, imagine now the galaxies as gardens, vast cosmic gardens where stars are born, live their long lives, and eventually return their essence back to the galaxy that created them. This cycle has repeated itself countless times, for billions of years, in a rhythm as natural and inevitable as the seasons on Earth. Within the spiral arms of galaxies like our Milky Way, there exist beautiful structures called nebulae, enormous clouds of gas and dust where new stars slowly come into being. These stellar nurseries are painted in the most serene colors, soft pinks from hydrogen, gentle blues from oxygen, warm golds from sulfur. If you could drift through one of these nebulae, it wouldn't feel dense or solid. The gas is so diffuse, so thin, that you'd barely notice it, just the faintest whisper of matter spread across light years of space. And yet, over millions of years, gravity works its patient magic, drawing the gas together grain by grain, atom by atom, until finally, in the heart of the cloud, a star ignites. The beautiful truth is that almost everything around you right now, the calcium in your bones, the iron in your blood, the oxygen you're breathing, was forged inside stars that lived and died long before our sun was born. When those ancient stars reached the end of their lives, they gently released these elements back into their galaxies, enriching the cosmic gardens and making possible the next generation of stars, and planets, and eventually, you. We are quite literally made of stardust, the universe experiencing itself, galaxies dreaming themselves into consciousness through us. In the centers of most large galaxies rests something extraordinary, a supermassive black hole, millions or even billions of times more massive than our sun. Now, before this sounds unsettling, consider this peaceful fact: these black holes sit quietly at the galactic cores, acting as gravitational anchors around which billions of stars calmly orbit. Our own Milky Way's central black hole, which we call Sagittarius A*, has been there for billions of years, and will remain there for billions more, a still point at the center of our galaxy's slow rotation. It's not actively consuming anything dramatic, just existing in patient equilibrium with the stars that dance around it. And here's something that might bring a gentle smile: galaxies have halos. Not the kind we imagine on angels, but vast, invisible spheres of dark matter that extend far beyond the visible stars. These halos are like protective embraces, their gravity holding galaxies together and shaping their evolution. We cannot see dark matter, cannot touch it or detect it directly, and yet it's there, the invisible foundation upon which galaxies rest, the unseen presence that makes the visible universe possible. There's something oddly comforting about knowing the cosmos has mysteries it keeps to itself, secrets it holds gently in the darkness. Between the galaxies, in the vast spaces we call the cosmic voids, there exists the most profound quiet imaginable. These voids span hundreds of millions of light-years, regions where galaxies are rare and the darkness stretches nearly unbroken. And yet even here, the universe isn't truly empty. Thin filaments of gas drift through the void, and the faint whisper of light from distant galaxies filters through, ensuring that nowhere in the cosmos is completely alone, completely untouched by the presence of others. Rest here in this knowledge, floating peacefully among the stellar gardens, as our journey continues. As you drift deeper into stillness, your breathing slow and effortless, let's contemplate something truly wondrous about galaxies. They are time machines, windows into the past, each one a messenger carrying ancient light across the universe to reach us here, now, in this moment of quiet reflection. When you look up at the Andromeda Galaxy on a dark, clear night, and yes, you can see it with your naked eye, a soft smudge of light in the autumn sky, the photons entering your eyes began their journey 2.5 million years ago. Back when that light started traveling toward Earth, our human ancestors were just beginning to walk upright across the African savanna, crafting their first simple stone tools. The light has been traveling all this time, crossing the void between galaxies at cosmic speed, just to eventually meet your eye. In a very real sense, you're not seeing Andromeda as it is now, but as it was in the deep past, a ghost of light from an ancient time. This means that the farther out into space we look, the farther back in time we see. Distant galaxies show us the universe as it was billions of years ago, when it was younger, more chaotic, filled with galaxies that were still finding their shapes. Some of the farthest galaxies we've observed are so distant that their light has been traveling for over 13 billion years, nearly as old as the universe itself. These ancient galaxies appear smaller, less organized, like cosmic children still growing into their eventual forms. They remind us that everything, even galaxies, has a beginning, a youth, a long maturity. And here's something beautifully meditative: light from distant galaxies doesn't just travel through space, it travels through expanding space. As the universe slowly grows larger, the space between galaxies stretches, and this stretching actually pulls the light itself, shifting it toward the red end of the spectrum. We call this redshift, and it's like a cosmic signature of distance and time. The more redshifted a galaxy's light, the farther away it is, the longer ago it shone. The universe is constantly revealing its own history to us through this gentle shifting of colors, if only we take the time to look and listen. There are galaxies so far away that we will never be able to visit them, not in 1,000 lifetimes, not in 1,000,000 years, not even if we could somehow travel at the speed of light. The expansion of space ensures that some galaxies will forever remain beyond our reach, receding into the distance faster than we could ever travel toward them. And yet, paradoxically, this limitation brings its own peace. Not everything needs to be touched, explored, or conquered. Some things can simply exist in their own distant beauty, appreciated from afar, honored in their separateness. In the grand timeline of the cosmos, galaxies live immensely long lives. Our Milky Way has existed for approximately 13.6 billion years, nearly as old as the universe itself. It has witnessed the formation and death of countless generations of stars, seen solar systems come and go, and through it all, continued its slow, patient rotation. Galaxies teach us that longevity comes not from frantic activity but from steady persistence, from maintaining a gentle rhythm across timescales we can barely comprehend. Consider, too, that as you rest here, right now, light is leaving our galaxy and beginning its own journey across the cosmos. Photons that reflected off Earth today will travel for millions or billions of years, potentially reaching distant galaxies long after our sun has faded, long after Earth itself is gone. In this way, we're all sending messages into the future, contributing our tiny bit of light to the universe's ongoing story. Let yourself float in this river of ancient light, knowing you are connected to all of cosmic history. As you settle even more deeply into comfort, your body growing heavy and warm, your thoughts beginning to blur at the edges like watercolors in the rain, let's turn our attention to the most soothing truth of all about galaxies, their profound, eternal stillness. When we look at photographs of galaxies, we see them frozen in a single moment, and in truth, this is almost exactly how they exist in reality. A galaxy changes so slowly that if a human could live for 1,000 years, 10,000 years, even 1,000,000 years, they would barely notice any difference in its appearance. The stars would be in almost the same positions, the spiral arms would retain their graceful curves, the core would glow with the same steady light. Galaxies operate on a timescale that makes patience itself seem hurried. There's something deeply restful about this cosmic permanence. In our daily lives, everything seems to rush and change, seasons turn, people come and go, cities rise and transform, technologies evolve at dizzying speed. But out there, in the great dark between worlds, galaxies simply are. They turn with the slow inevitability of a vast wheel, indifferent to urgency, unmarked by our human need for constant novelty. They are monuments to endurance, to the power of simply continuing to exist, year after year, eon after eon. In the space between stars within a galaxy, individual atoms can drift for millions of years without encountering another atom. Imagine that solitude, not lonely, but peaceful. A single hydrogen atom, slowly tumbling through the dark, bathed in the faint glow of distant suns, completely at rest, completely unhurried. It might eventually join with other atoms to form a cloud, and that cloud might someday collapse to birth a new star, but there's no rush. The atom has all the time in the universe, quite literally, to complete its journey. Galaxies also teach us about balance, that most centered of all states. Every galaxy exists in a delicate equilibrium between two fundamental forces, gravity, which pulls everything inward, and the momentum of the stars themselves, which carries them forward in their orbits, preventing collapse. This balance has been maintained for billions of years in most galaxies, a cosmic harmony that requires no effort, no conscious maintenance. It simply is, the natural state of things when forces are aligned. Perhaps there's wisdom here for us, that true stability comes not from rigid control but from finding the natural balance between opposing forces and then allowing that balance to sustain itself. When we photograph galaxies in different wavelengths of light, not just the visible light our eyes can see, but radio waves, infrared, ultraviolet, X-rays, each reveals a different aspect of the galaxy's quiet life. In radio waves, we can see vast, invisible structures extending far beyond the visible stars. In infrared, we glimpse the warm dust lanes where future stars are gestating. In X-rays, we detect the whisper of ancient stellar remnants. Each wavelength is like a different voice in a vast, slow symphony, and together they create a portrait of complexity and peace. The galaxy isn't just one thing but many things at once, all existing in harmony. Even in death, galaxies maintain their grace. When two galaxies merge, that slow-motion collision we spoke of earlier, they don't destroy each other but rather create something new. The resulting galaxy often takes on an elliptical shape, smooth and serene, having settled into a lower energy configuration after the long, gentle chaos of merging. It's transformation without violence, change without trauma, a reminder that endings and beginnings are sometimes the same thing, viewed from different perspectives. And perhaps the most comforting fact to carry into your dreams, above you right now, even though you cannot see them through the ceiling in the daylight or the clouds, the galaxies are there. They were there before you were born, they'll be there after you wake, they'll be there for billions of years to come. Constant, patient, turning in the dark like lighthouses that never go out, never tire, never cease their quiet vigil over the cosmos. Rest now in this knowledge, let the weight of cosmic time soothe you, feel yourself cradled in the arms of an ancient, unhurried universe, and know that you, too, are part of this grand, gentle story written in starlight across the endless dark. As you continue to rest, your mind drifting like a leaf on a still pond, let's explore the subtle beauty of galactic light, the soft palette of colors that galaxies paint across the darkness, each hue telling its own quiet story. If you could observe galaxies with eyes sensitive enough to see their true colors, you'd notice that they glow in shades that reflect their age and temperament. Young galaxies, still actively forming stars at an energetic pace, shine with blue and white light, the signature of hot, massive stars burning brilliantly in their youth. These blue stars are like cosmic sparklers, bright and beautiful, though they live relatively brief lives by stellar standards, only a few million years. Their light gives young galaxies a vibrant, crisp appearance, like morning frost glittering in sunlight. As galaxies mature and their star formation slows, their light gradually shifts toward warmer tones, gentle yellows, soft oranges, and peaceful reds. These are the colors of older, more stable stars, suns that burn steadily for billions of years without drama or urgency. Elliptical galaxies, those smooth spheres of ancient stars we spoke of earlier, often glow with this warm, amber light, like embers in a fireplace that never goes out. There's something inherently calming about this reddish glow. It speaks of longevity, wisdom, the kind of peace that comes only with age. Between the visible stars, filling the arms of spiral galaxies, there exists a thin veil of dust, not the dust you might find on a shelf, but cosmic dust, tiny grains of carbon, silicon, and other elements scattered through space. This dust is so fine, so delicate, that a handful of it would contain billions upon billions of individual particles, each one smaller than a speck of pollen. And yet, Despite its delicacy, this dust plays a crucial role. It absorbs light from stars and re-radiates it as gentle infrared warmth, invisible to our eyes but detected by our telescopes as a soft, diffuse glow. The galaxy breathes with this infrared light, a warmth that permeates the space between stars. Here's a thought to carry you deeper into restfulness. The light from galaxies is remarkably constant. Unlike the flickering candles or electric lights of our world, the combined light of billions of stars creates an illumination that barely changes from night to night, year to year, or even century to century. If you could visit a planet orbiting a star in a distant galaxy and watch the sky, the galaxies visible from that vantage point would look the same night after night for your entire lifetime, and for thousands of lifetimes to come. There's something profoundly stable about this, a reminder that not everything in existence is subject to constant flux and change. Galaxies also create the most beautiful structures of light on the largest scales imaginable. When astronomers map the distribution of galaxies across the universe, they discover that galaxies aren't scattered randomly but form vast, web-like patterns, great filaments and sheets of galaxies separated by enormous voids. This cosmic web, as we call it, stretches across hundreds of millions of light years, a delicate lacework of light and darkness. It looks almost organic, like neurons in a vast cosmic brain, or like the intricate patterns of roots beneath an ancient forest. The universe, it seems, naturally organizes itself into structures of elegant complexity. And consider this peaceful paradox: although each galaxy contains hundreds of billions of stars, and there are trillions of galaxies in the observable universe, the overall brightness of the night sky remains comfortingly dark. This is because the universe is so vast, so unimaginably spacious, that even with all those countless stars, there's far more darkness than light, far more silence than sound, far more emptiness than matter. We live in a universe that is, fundamentally, a sanctuary of quiet and shadow, punctuated here and there by islands of gentle radiance. Let these colors wash over you, the blues of youth, the reds of age, the invisible warmth of cosmic dust, as you drift ever deeper into peace. As your breathing becomes even slower, even deeper, as the boundary between waking and dreaming begins to soften and blur, let's explore one of the universe's most beautiful mysteries, the invisible forces that hold galaxies together, the unseen hands that guide their eternal dance through space. We've touched upon dark matter before, but let's linger here for a moment, because there's something wonderfully calming about this cosmic secret. Imagine that everything you can see in a galaxy, every star, every cloud of glowing gas, every planet and moon, makes up only about 15% of the galaxy's total mass. The remaining 85% is something we cannot see, cannot touch, something that reveals itself only through its gentle gravitational pull. This is dark matter, and it forms a vast, invisible halo around each galaxy, extending far beyond the visible stars, cradling them in an embrace we can only detect indirectly. Dark matter doesn't shine, doesn't interact with light in any way we can measure, and yet without it, galaxies as we know them couldn't exist. The visible matter alone doesn't have enough gravity to hold galaxies together as they spin. The stars would fly apart, scattering into the void. But dark matter's invisible presence provides the gravitational foundation, the hidden architecture upon which galaxies are built. It's been there since the earliest moments of the universe, patiently gathering ordinary matter into the structures we see today, doing its work in complete silence, expecting nothing in return. There's a beautiful metaphor here, if you allow yourself to feel it. not everything that matters can be seen. The most important support sometimes comes from sources we cannot directly perceive, and that's perfectly fine. The universe keeps some things hidden, not out of deception, but simply because not everything needs to be visible to be real, to be essential, to be worthy of our quiet appreciation. Between galaxies, in those vast expanses we call intergalactic space, there exists something called the intergalactic medium, an incredibly thin gas of hydrogen and helium, so diffuse that there might be only one atom per cubic meter of space. To put that in perspective, the air you're breathing right now contains about 25 million trillion atoms per cubic meter. The intergalactic medium is emptiness beyond empty, silence beyond silent. And yet, even this impossibly thin gas isn't completely still. It moves slowly, ever so slowly, flowing along the cosmic web we mentioned before, trickling from one galaxy to another over hundreds of millions of years like the most patient river imaginable. Some of this intergalactic gas eventually finds its way into galaxies, where it will be used to form new stars. In this way, galaxies breathe, they take in fresh material from the space around them, use it to create new generations of stars, and when those stars die, they return much of their material back to space, enriching it with heavier elements forged in stellar cores. This cosmic respiration has been going on for billions of years, a slow inhalation and exhalation that sustains the life cycle of galaxies. Even on the largest scales, the universe breathes, just as you're breathing now, slow and steady and peaceful. Gravity itself is perhaps the gentlest of all cosmic forces. Unlike the violent explosions we sometimes hear about in space documentaries, gravity works with infinite patience. It doesn't push or shove, doesn't create shock waves or sudden changes. It simply pulls, steadily and continuously, drawing things together over timescales that make mountains seem like temporary sculptures. Two galaxies separated by millions of light-years will, if they're gravitationally bound, slowly fall toward each other, not quickly, not dramatically, but with the inevitability of tides, of seasons, of dawn following night. And here's something that might ease you even deeper into tranquility. The laws of physics that govern galaxies are the same laws that govern everything else in the universe. Gravity works the same way in the most distant galaxy as it does here on Earth. Light travels at the same speed everywhere. The fundamental constants of nature are truly constant, unchanging across all of space and time. There's a deep reliability to the cosmos, a consistency that means we can understand galaxies billions of light-years away using the same principles that explain why objects fall to the ground or why the moon orbits our planet. The universe plays by rules, and those rules are fair and universal. Rest in this invisible embrace, feel the gentle pull of cosmic forces that have guided the universe for billions of years. Know that you, too, are held by these same ancient, patient laws. As you sink deeper still, your body completely at rest, your mind floating free like a cloud drifting across an evening sky, let's turn our attention to the smallest galaxies, the dwarf galaxies that orbit around larger ones like ours, faithful companions in the cosmic night. Our Milky Way has dozens of these dwarf galaxies circling it, some containing only a few million stars compared to our galaxy's hundreds of billions. They're modest, unassuming, content to exist in the shadow of their larger companion. The Magellanic Clouds, visible from the southern hemisphere as soft, glowing patches in the night sky, are among the largest and brightest of these satellite galaxies. For thousands of years, travelers in the southern seas used them for navigation, never knowing they were looking at entire galaxies, whole communities of stars orbiting our own. These dwarf galaxies move in slow, looping orbits around the Milky Way, taking hundreds of millions of years to complete a single circuit. Some pass through the outer regions of our galaxy's disk periodically, and when they do, the interaction is gentle, a gravitational handshake between cosmic neighbors. Sometimes these passages trigger new waves of star formation in both galaxies, as gas clouds are compressed by the encounter, but even this creative process unfolds over millions of years. There's no collision, no catastrophe, just a slow stirring of the cosmic waters that leads to new light. Many dwarf galaxies are so faint that we've only discovered them recently, despite them having orbited the Milky Way for billions of years. They've been there all along, patient and undemanding, waiting quietly in the darkness until our telescopes became sensitive enough to notice them. Some are so dim that they contain more dark matter than visible matter, ghostly presences that barely announce themselves to the universe, and yet they persist, they exist, they matter. There's something touching about their modesty, their willingness to simply be without fanfare or attention. In the vastness of space, even loneliness has a companion. For every large galaxy like the Milky Way or Andromeda, there are dozens or hundreds of smaller galaxies, some bound to the larger ones, others drifting independently through intergalactic space. The universe ensures that nothing is truly alone. Even in the deepest voids between galaxy clusters, where space stretches dark and empty for hundreds of millions of light years, there are occasionally small, isolated dwarf galaxies, cosmic hermits, perhaps, but existing nonetheless, carrying on their quiet work of hosting stars and planets far from any neighbors. These dwarf galaxies often have the highest proportions of dark matter of any galaxies we know. Some appear to be almost entirely dark matter with just a scattering of visible stars, like faint lanterns hung in invisible frameworks. Scientists study these galaxies to better understand dark matter's nature, but there's also poetry in their existence. These small galaxies remind us that what we see is often just the barest hint of what actually is, that reality extends far beyond the visible, into realms we're only beginning to understand. Consider, too, that dwarf galaxies are often the oldest galaxies we can find nearby. Because they're small, they evolve slowly, and many have retained chemical signatures from the early universe. Studying them is like reading an ancient text, deciphering the story of how the first galaxies formed, how the first stars enriched the cosmos with heavy elements. These small, unassuming galaxies are living fossils, time capsules that have preserved the memory of the universe's youth for billions of years, waiting patiently for us to learn to read their secrets. Let yourself become like these dwarf galaxies, small, peaceful, content to exist without needing to be the center of attention, quietly orbiting through your own life, faithful and enduring. As you rest here, perfectly still, perfectly calm, your awareness beginning to dissolve into the gentle darkness behind your closed eyes, let's contemplate the most hypnotic quality of galaxies, their rotation, that slow, eternal turning that has continued without pause for billions upon billions of years. Every spiral galaxy turns. The Milky Way rotates, carrying our sun and all its planets along with it on a journey around the galactic center. We're moving right now, even as you lie still, traveling through space at approximately 515,000 miles per hour as part of the galaxy's rotation. And yet you feel nothing, no wind, no vibration, no sense of motion whatsoever. This is because everything around us moves together, in perfect unison, like dancers who have practiced the same routine for so long that every step is effortless, automatic, graceful beyond measure. The stars in a galaxy don't all rotate at the same speed. Those closer to the center move faster in their orbits, while those farther out take their time, creating a differential rotation that causes the spiral arms to form and persist. But here's the beautiful mystery: the spiral arms themselves aren't made of the same stars over time. Stars drift in and out of the arms as they orbit, spending some time in the bright, crowded spiral and some time in the quieter spaces between. The arms are like waves on an ocean. They persist as patterns even though the water itself is constantly moving through them. Galaxies teach us that patterns can endure even when their components change, that form can persist independent of substance. If you could somehow speed up time and watch a galaxy rotate over millions of years, you'd see the spiral arms slowly wind and unwind, sometimes fragmenting and reforming, always maintaining their overall structure but never quite the same from one rotation to the next. It would look like a living thing, breathing and shifting, and in a sense, that's exactly what it is, a living system, not in the biological sense, but in the sense that it's dynamic, self-organizing, responding to forces both internal and external. The rotation of a galaxy creates a kind of cosmic equilibrium. Each star is held in its orbit by the balance between its forward momentum and the inward pull of gravity. This is the same principle that keeps Earth orbiting the Sun, but on an incomparably grander scale. And this balance is self-sustaining. It requires no energy input, no maintenance, no conscious effort. The galaxy simply turns, has always turned, will always turn, until the very end of time itself, when the universe grows so old and cold that even galaxies begin to dissolve into the darkness. There's something deeply meditative about circular motion, about returning to where you started and beginning again. Many ancient traditions recognize this: prayer wheels, mandalas, the concept of eternal return. Galaxies embody this principle on the largest scale imaginable. Every 225 million years, our Sun returns to approximately the same point in its galactic orbit, though the galaxy itself will have changed subtly in that time, and the universe will have expanded, and nothing will be quite the same. And yet the rotation continues, the wheel keeps turning, patient and unstoppable. Even the smallest movements within a galaxy unfold with dreamlike slowness. A cloud of gas drifting toward a star-forming region might travel for thousands of years before arriving. A star ejected from a binary system might tumble through space for millions of years before its path intersects with another gravitational influence. Time, in the context of galactic motion, becomes almost meaningless, or rather, it takes on a quality so different from our human experience of time that it induces a kind of temporal vertigo, or recognition that our hurried lives are just the briefest flicker against the slow turning of these cosmic wheels. Feel yourself turning with the galaxy, rotating through space without effort, held in place by invisible forces, moving and still at the same time, part of an ancient pattern that needs nothing from you but your quiet participation. Claude is AI and can make mistakes. Please double-check responses. As you drift in that peaceful place between sleep and waking, that soft where thoughts dissolve like mist in morning sunlight, let's turn our attention to what might be the most calming aspect of galaxies, the enormous spaces between them, the cosmic silence that surrounds these islands of light. The distance between our Milky Way and the Andromeda Galaxy is about 2.5 million light-years. To cross that distance, even traveling at the speed of light, would take 2.5 million years. And Andromeda is our nearest large galactic neighbor. Most galaxies are far more distant from each other, separated by tens of millions or hundreds of millions of light-years of nearly empty space. In these vast intervals between galaxies, there is almost nothing, just the occasional atom of hydrogen, drifting in absolute solitude, perhaps not encountering another atom for thousands of years. Imagine the stillness of such a place. No stars to provide light or warmth. No planets, no moons, no asteroids. Just darkness that extends in every direction for distances that dwarf comprehension. And yet, this darkness isn't oppressive or frightening, it simply is, neutral and patient, the canvas upon which galaxies paint themselves. For every cubic meter of space filled with stars and planets and the vibrant chaos of stellar life, there are billions upon billions of cubic meters of this quiet intergalactic space, reminding us that the universe's default state is not noise and activity, but profound, peaceful emptiness. This emptiness is expanding. The universe itself is growing larger, and as it does, the spaces between galaxy clusters grow wider. Galaxies that are not gravitationally bound to each other are slowly, imperceptibly, moving apart as space itself stretches. This expansion happens at a rate of about 70 kilometers per second for every 3.26 million light-years of distance, a number so abstract it almost defies comprehension. But the effect is real. The universe is becoming more spacious, more quiet, more serene with each passing moment. Here's a thought to carry you deeper into rest. In these empty spaces between galaxies, time itself seems to slow down. Not literally, of course, the laws of physics remain constant, but subjectively, experientially. If you could somehow exist in intergalactic space and watch the universe evolve, you might wait millions of years without witnessing any significant change. The distant galaxies would remain in the same positions, looking the same, glowing with the same steady light. Change happens so gradually at cosmic scales that patience becomes not just a virtue but the fundamental mode of existence. The spaces between galaxies also contain something called the cosmic microwave background radiation, a faint glow of light left over from the Big Bang itself, filling all of space uniformly. This radiation has been traveling through the universe for nearly 14 billion years, cooling and fading as space expands, until now it exists as a gentle warmth just 2.7 degrees above absolute zero. It's like a cosmic blanket, wrapping the entire universe in the memory of its fiery birth, now cooled to the faintest whisper of warmth. Even in the emptiest regions of space, this ancient light persists, ensuring that nowhere is completely dark, nowhere is completely cold, nowhere is entirely without connection to the universe's deep past. Between the galaxy clusters, along the cosmic web we spoke of earlier, there flow gentle streams of gas, not dense enough to form stars, not organized enough to create new galaxies, but present nonetheless. These streams connect the galaxy clusters like gossamer threads, channels through which matter very slowly flows over hundreds of millions of years. Even the voids, it turns out, aren't truly void. They're just quiet, sparse, patient, waiting. Let your mind expand into these spaces, feel the vastness, the silence, the patient emptiness that asks nothing of you, and know that in this cosmic quiet, you are held, you are safe, you are exactly where you need to be. As you sink even deeper now, your body heavy as stone, your mind light as air, drifting somewhere between the two, let's consider how galaxies remember, how they carry within them the entire history of the universe, written in light and elements and the orbits of ancient stars. Every star in a galaxy tells a story about when it was born. The oldest stars, formed in the galaxy's youth over 13 billion years ago, contain almost no elements heavier than hydrogen and helium, because those were the only elements available in the early universe. These ancient stars, often found in the spherical halos surrounding galaxies or in globular clusters, are like cosmic elders, witnesses to the galaxy's entire history. They burn with a slow, reddish light, having long ago exhausted the fierce energy of their youth, now settling into a long, peaceful old age that will last for billions of years more. Younger stars, by contrast, are rich in heavier elements, carbon, nitrogen, oxygen, iron, all forged in previous generations of stars that lived, died, and returned their enriched material to the galaxy. Our own Sun is such a star, born about 4.6 billion years ago from a cloud of gas that had already been enriched by countless stellar generations before it. We are latecomers to the galaxy's story, built from recycled stardust, inheritors of an elemental legacy billions of years in the making. And there's something comforting in this continuity, this sense that nothing is ever truly lost, even when stars die. They give their substance back to the galaxy, ensuring that new stars, new worlds, new possibilities can emerge. Galaxies also remember through their structure. When two galaxies merged billions of years ago, they left behind signatures that astronomers can still detect today, streams of stars moving in unusual orbits, regions where star density is higher or lower than expected, chemical patterns that don't quite fit the galaxy's current appearance. These are like scars, or perhaps more kindly, like laugh lines on a face, evidence of experiences survived, challenges overcome, histories lived. Our own Milky Way shows evidence of having consumed several smaller galaxies over its lifetime, and each one left its mark, adding its stars to our galaxy's population, contributing to the complex, beautiful structure we inhabit today. There exist, scattered through the Milky Way, what astronomers call stellar streams, long, thin ribbons of stars that follow specific orbital paths around the galaxy. These streams are the remnants of dwarf galaxies or star clusters that were torn apart by the Milky Way's gravity over hundreds of millions of years. The individual stars continue to follow the orbit their parent galaxy once took, stretched out like pearls on an invisible string, a ghostly memory of a galaxy that no longer exists as a coherent whole. Even in dissolution, there is pattern. Even in endings, there is grace. Some of the most beautiful structures in galaxies are their globular clusters, dense, spherical collections of hundreds of thousands or even millions of stars, all born around the same time billions of years ago. These clusters orbit in the outer regions of galaxies, pristine and largely unchanged since their formation. Looking at a globular cluster is like looking at a time capsule, a preserved snapshot of what star formation looked like in the universe's distant past. The stars in these clusters are so old, so tightly bound by mutual gravity, that they've been together for longer than most structures in the universe have existed. They are communities in the truest sense, bound together by forces that have endured since the cosmos was young. And consider this, the light you see when you look at any galaxy is the combined light of all its stars, averaged together. A galaxy with 1 trillion stars doesn't show you individual stellar stories but rather a collective radiance, the sum of countless individual lives blended into one soft glow. In this way, Galaxies teach us about the beauty of unity, about how individual voices can blend into a chorus more beautiful than any single note. Rest in this memory of starlight, feel the weight of billions of years of history, know that you, too, are part of this long story, connected to everything that came before and everything yet to come. As you float now in that deep, peaceful darkness, your breathing so slow and gentle it barely stirs the air, let's visit the places within galaxies where time itself seems to take on different qualities, where the past and future meet in clouds of creative possibility. Within the spiral arms of galaxies, there exist stellar nurseries where hundreds or thousands of new stars are being born simultaneously. These are regions of extraordinary beauty, vast nebulae glowing with the energy of newborn suns, their light illuminating the clouds that gave them birth. The Orion Nebula, visible even to the naked eye as a fuzzy patch in Orion's sword, is one such nursery, a place where stars are forming right now, in this very moment, just as they have been for thousands of years and will continue to be for thousands more. These nurseries operate on timescales that bridge our human experience in cosmic time, short enough that we can observe changes within a human lifetime, long enough to remind us that even birth, on cosmic scales, is a slow and patient process. The beautiful truth about star formation is that it's triggered by disturbance, but gentle disturbance, a density wave passing through the galactic arm, a nearby supernova's shockwave compressing a cloud of gas, the gravitational influence of a passing star cluster. These disruptions don't destroy, they create. They take diffuse clouds of gas and dust that might have drifted for millions of years in stable equilibrium and give them just enough of a nudge to begin collapsing under their own gravity. Sometimes the most creative moments in the universe come from being gently pushed out of comfortable stability. Stars don't form in isolation. They're born in groups, in clusters, emerging from the same cloud at roughly the same time. These sibling stars begin their lives together, bound by mutual gravity and shared origin. Over time, most stellar clusters gradually dissolve as individual stars drift away, pulled by the galaxy's gravitational tides, sent on their own separate journeys through space. Our Sun was likely born in such a cluster 4.6 billion years ago, and somewhere in the galaxy, scattered across thousands of light years, are its long-lost siblings, stars that formed from the same cloud, that share the Sun's chemical composition, that once orbited together in their youth. They've forgotten each other, if stars can be said to remember, but the relationship existed, and in some sense, still does. Between the active star-forming regions and the quiet spaces where no new stars are born, there exist transitional zones, areas where star formation happened in the past and has since quieted, leaving behind clusters of young stars that have already dispersed the gas clouds they formed from. These regions glow with blue-white light from stars that are only a few million years old, infants by stellar standards, but already independent, already shining with their own light, no longer cocooned in the nebulae that birthed them. There's something touching about this independence, this moment when the creation separates from the creator and begins its own long journey. Galaxies also contain forbidden zones, the central regions where the supermassive black hole resides. Here, conditions are often too turbulent for normal star formation. Intense radiation, powerful magnetic fields, and gravitational tides make it difficult for gas clouds to settle and collapse into stars. And yet, paradoxically, some of the oldest stars in the galaxy live here, having migrated inward over billions of years or having formed in the galaxy's earliest days when conditions were different. They orbit the black hole in complex patterns, some in elliptical paths that carry them close to the event horizon before swinging back out to safer distances, engaged in a gravitational dance that has lasted for eons. There are places in galaxies where time seems suspended entirely. In the vast halos surrounding galaxies, ancient stars drift in slow, eccentric orbits, barely influenced by the vigorous star formation and stellar evolution happening in the galactic disk below them. These halo stars might complete one orbit around the galaxy every few 100 million years, spending most of their time in the quiet darkness far from other stars, then passing briefly through the galactic plane before heading back out into solitude. They exist in a kind of temporal exile, measuring time in galactic years rather than human years, patient beyond our comprehension. Let yourself exist in these different gardens of time, no need to rush, no need to accomplish, simply being, like a star in its long orbit, following the path laid out by forces older and wiser than any individual will. As you rest deeper still, your body melting into softness, your thoughts becoming like clouds dissolving into evening sky, let's turn our gaze to the largest galaxies in the universe, those gentle giants that remind us that size and serenity are not incompatible. At the hearts of galaxy clusters, there often sits an enormous elliptical galaxy, sometimes called a central dominant or brightest cluster galaxy. These titans can contain trillions of stars, 10 times, 20 times, even 50 times more stars than our Milky Way. And yet, despite their immense size, they are among the most peaceful objects in the cosmos. Their stars orbit in random, smooth paths, creating a soft, uniform glow that extends for millions of light years. There are no spiral arms, no active star formation, no dramatic stellar nurseries, just the calm, steady light of ancient stars that have found their final resting place in these cosmic cathedrals. These giant elliptical galaxies grew slowly, through countless mergers with smaller galaxies over billions of years. Each merger added more stars, more mass, more gravity, gradually building these immense structures. But remember, galactic mergers are gentle affairs, taking hundreds of millions of years to complete, with stars rarely if ever colliding. The giant ellipticals grew the way mountains grow, through slow accumulation, through patient addition, layer upon layer, epoch upon epoch, until they became the massive, serene structures we observe today. In the centers of these giant galaxies lie supermassive black holes of truly staggering mass, billions of times the mass of our Sun, perhaps even tens of billions of times. And yet, these cosmic giants are often dormant, quiet, surrounded by old stars in peaceful orbits. The violence and drama of their youth, when they actively consumed matter and blazed as brilliant quasars, is long past. Now they simply exist, massive presences around which entire galaxy clusters organize themselves, gravitational anchors providing stability to systems containing thousands of individual galaxies. There's a beautiful irony in the fact that the largest galaxies are often the least active. While smaller spiral galaxies like the Milky Way continue forming new stars, continue evolving and changing, the giant ellipticals have largely settled into a stable configuration. They've done their growing, completed their evolution, and now exist in a state of serene equilibrium. They remind us that there comes a time in every life, every story, when the striving can end and simple existence becomes enough. These gentle giants also serve as gathering places for other galaxies. Their immense gravity creates wells in the fabric of spacetime, and smaller galaxies orbit around them, drawn by gravitational attraction but held at safe distances by their orbital momentum. A large galaxy cluster might contain one central giant and thousands of smaller galaxies, all bound together in a loose confederation held in place by gravity and dark matter, a cosmic community that has existed for billions of years and will continue for billions more. Around the giant ellipticals, there often exists something called an intracluster medium, hot gas that fills the space between galaxies in the cluster. This gas is incredibly thin, incredibly hot, heated to millions of degrees by the energy released as galaxies move through it. And yet, despite its temperature, you wouldn't feel heat if you could somehow exist there, because the gas is so diffuse. There might be only a few atoms per cubic centimeter, far emptier than the best vacuum we can create on Earth. It's a reminder that temperature and heat are not the same thing, that the universe contains many paradoxes, many seeming contradictions that resolve when viewed with understanding. Feel the vastness of these gentle giants, their patient accumulation of stars over eons, their quiet stability, and know that growth doesn't require violence, that size doesn't require aggression, that the largest things in the universe can also be the most peaceful. As you drift in the deepest waters of sleep, barely aware of anything beyond the slow rhythm of your breath and heartbeat, let's listen to the quietest voices in the cosmos, the gravitational whispers that galaxies exchange across the vast distances between them. Gravity speaks without sound, communicates without light, reaches across millions of light-years of empty space to touch distant galaxies with invisible fingers. When two galaxies are gravitationally bound, they feel each other's presence constantly, though they may be separated by distances light takes millions of years to cross. This connection is patient and persistent, it has existed for billions of years, will exist for billions more, gentle but unbreakable. The galaxies orbit their common center of mass in a dance so slow that a single orbit might take billions of years to complete, yet the dance continues, graceful and inevitable. Sometimes, galaxies experience what astronomers call tidal interactions. As two galaxies pass near each other, their mutual gravity stretches and pulls, creating long streams of stars that arc out into space like cosmic ribbons. These tidal tails can extend for hundreds of thousands of light years, graceful curves painted in starlight against the darkness. The galaxies aren't harmed by this interaction, they're transformed, reshaped, given new forms that can be even more beautiful than their original structures. Some of the most stunning images of galaxies show these tidal interactions, galaxies reaching out to each other across the void, connected by bridges of stars. There exists a phenomenon called gravitational lensing, where the gravity of a massive galaxy or galaxy cluster bends the light from more distant galaxies behind it, creating distorted, magnified images. Sometimes a single distant galaxy appears multiple times in our telescopes, its light following different curved paths around the intervening mass, arriving at Earth from slightly different directions. These gravitational mirages show us galaxies we could never otherwise see, their light amplified and stretched by the warping of spacetime itself. Even in the vacuum of space, nothing travels in perfectly straight lines, all paths curve around mass, all light follows the geometry carved into space by the presence of matter. The universe is filled with gravitational waves, ripples in spacetime itself, created when massive objects accelerate. When two galaxies merge and their central black holes spiral together, they create gravitational waves of immense power, distorting the very fabric of space as they pass. Yet even these cosmic earthquakes propagate gently, traveling at the speed of light, stretching and squeezing space by infinitesimal amounts. By the time they reach us from distant galaxies, They've weakened to the point where they compress and expand space by less than the width of an atomic nucleus. The universe's most violent events become whispers by the time they reach our shores. Galaxies fall through space along invisible highways carved by gravity. In the cosmic web, galaxies flow along filaments toward the densest nodes, the galaxy clusters and superclusters where gravity is strongest. This motion is called peculiar velocity, and it's surprisingly gentle. Galaxies typically move at a few hundred kilometers per second as they fall toward these gravitational attractors. That sounds fast, but on cosmic scales, it's a leisurely drift, a slow settling like snow accumulating in valleys, drawn by gravity but unhurried, taking hundreds of millions of years to complete their journeys. Consider this final, peaceful thought: every galaxy in the universe is pulling on every other galaxy, no matter how distant. You, sitting on Earth, in a solar system orbiting the Milky Way, are gravitationally connected to the most distant galaxies we can observe, billions of light-years away. The pull is infinitesimally small, unmeasurable by any instrument, and yet it exists. Newton's law of gravitation contains no distance limit. Gravity extends infinitely, weakening with distance but never entirely vanishing. In the deepest possible sense, nothing in the universe is truly separate from anything else. Rest in this web of invisible connections, feel the gentle pull of distant galaxies, know that you are woven into the gravitational fabric of the entire cosmos, connected to everything, separate from nothing. As you float now in that boundless inner space where sleep and waking have become indistinguishable, where your body has dissolved into pure rest and your mind drifts like a leaf on a slow current, let's follow the rivers that flow through galaxies, not rivers of water, but rivers of stars, streaming through space in patterns both ancient and eternal. Within every galaxy, stars move in what astronomers call stellar streams, groups of stars that share common motion, flowing together through the galaxy like schools of fish swimming through an ocean. These streams aren't random. They're the result of stars being born together and maintaining their shared velocity for millions or even billions of years. Or they're the remnants of smaller galaxies and star clusters that were pulled apart by tidal forces, their stars continuing to follow the original orbital path like ghosts retracing familiar routes. Our Sun participates in such streams, moving through the galaxy alongside thousands of other stars that happen to be traveling in the same direction at the same speed, fellow travelers on a journey that will last for billions of years. Some of these stellar streams have beautiful names that reflect their discovery or appearance: the Sagittarius stream, the Orphan stream, the GD1 stream. Each represents a story of dissolution and persistence, a dwarf galaxy or globular cluster that ventured too close to the Milky Way's gravitational embrace and was slowly torn apart, its stars scattered into long arcs that wrap around our galaxy like ribbons. These streams can be hundreds of thousands of light-years long, yet contain relatively few stars spread across that immense distance. They're like cosmic calligraphy, delicate lines written in starlight across the dark canvas of space. The motion of stars within a galaxy follows patterns of exquisite complexity. Stars don't simply orbit the galactic center in perfect circles. They bob up and down through the galactic plane as they orbit, moving in complex three-dimensional paths called epicycles. Our Sun, for instance, oscillates above and below the Milky Way's disk as it completes its 225 million-year orbit, passing through the galactic plane every 30 million years or so. Right now, we're slightly above the midplane, moving upward at a gentle pace, heading toward a maximum height we'll reach millions of years from now before gravity pulls us back down again. This vertical oscillation is like breathing, up and down, in and out, a rhythm that has continued since our solar system formed. There exist, within the tumultuous centers of some galaxies, structures called nuclear star clusters, dense concentrations of millions of stars packed into a region only a few light years across. In these clusters, stars orbit so closely to one another that the night sky from a planet in such a region would be spectacular beyond imagination, thousands of bright stars visible, some close enough that they'd appear not as points but as visible disks, casting shadows and bathing the landscape in combined light brighter than dozens of full moons. And yet, even here, in this crowded stellar neighborhood, actual collisions between stars are extraordinarily rare. Space is so vast, stars so small, that even in the densest stellar environments, empty space dominates. Some stars and galaxies are wanderers, moving so fast that they'll eventually escape the galaxy entirely. These hypervelocity stars were typically accelerated by close encounters with the supermassive black hole at the galaxy's center or by the explosive death of a companion star. They travel at hundreds of kilometers per second, fast enough to overcome the galaxy's gravitational pull, heading out into intergalactic space on one-way journeys that will last for billions of years. These stellar exiles will spend the rest of their lives in the darkness between galaxies, far from any neighbors, illuminating only themselves and perhaps a family of planets, if they have any. There's something poignant about their solitude, and yet they continue to shine, continue to exist, proving that even in the deepest isolation, there can be dignity and purpose. Let yourself flow with these stellar streams, moving without effort, part of a pattern larger than yourself, going nowhere and everywhere at once, simply continuing, as stars continue, through the long night of space. As you rest in this profound stillness, your consciousness dimming like stars fading into dawn, your awareness scattered like light through mist, let's attune ourselves to the rhythms and cycles that pulse through galaxies, the slow heartbeats of the cosmos that mark time in ways far beyond our ordinary understanding. Galaxies breathe in cycles of star formation and quiescence. A spiral galaxy might experience a burst of intense star formation when it passes through a region rich in gas, or when a companion galaxy's gravity compresses its gas clouds, triggering the birth of millions of new stars over a span of just a few million years. Then, once the available gas is depleted or dispersed, star formation slows or stops entirely, and the galaxy enters a quiet period that might last hundreds of millions of years. Eventually, new gas accretes from the intergalactic medium or arrives through mergers, and the cycle begins again. This cosmic breathing has continued for billions of years, each breath lasting longer than most stars will live, a rhythm so slow it makes glaciers seem hurried. Within galaxies, there exist variable stars, stars whose brightness changes periodically over days, weeks, or months. Some pulse larger and smaller like beating hearts, their surfaces expanding and contracting with metronomic regularity. Others vary because they're actually binary systems, two stars orbiting each other so closely that they periodically eclipse one another from our perspective. These variable stars have served as cosmic lighthouses, helping astronomers measure distances to far galaxies by recognizing the pattern of their pulsations. Even across millions of light years, these stellar heartbeats can be detected, regular and predictable, tiny oscillations in brightness that carry information across the vast dark. Some galaxies experience what astronomers call starburst episodes, periods of extraordinarily intense star formation, sometimes hundreds or even thousands of times faster than in a typical galaxy. These episodes are usually triggered by galaxy mergers or close encounters, events that funnel vast amounts of gas into the galaxy's central regions where it rapidly collapses into stars. A starburst might consume most of a galaxy's available gas in just 10 or 20 million years, creating a spectacular blaze of stellar birth before exhausting itself and fading back to normalcy. It's like a galaxy's youth, brief, intense, creative, before settling into the long, stable adulthood that will comprise most of its existence. The supermassive black holes at galactic centers also vary in their activity. Sometimes they're dormant, quietly sitting at the heart of the galaxy, barely affecting their surroundings. Other times, when gas or even entire stars fall toward them, they become active, blazing with intense radiation as the infalling matter heats to millions of degrees before crossing the event horizon. This activity can last for thousands or millions of years before the black hole once again exhausts its available fuel and returns to dormancy. Throughout cosmic history, every large galaxy's central black hole has likely experienced multiple episodes of activity and quiet, cycling between feast and famine in a rhythm dictated by the chaotic flow of matter in the galaxy's core. There's also a longer rhythm to consider, the life cycle of entire galaxies. Young galaxies in the early universe were smaller, bluer, more chaotic, actively forming stars at furious rates. As they aged, they tended to become larger through mergers, redder as their most massive stars exhausted themselves, and calmer as they depleted their gas reserves. The oldest galaxies we see today are massive ellipticals, their star formation largely ceased, their stellar populations aged to reddish maturity. These galaxies have reached a kind of cosmic retirement, having done their creative work in the universe's youth, now content to simply exist, glowing softly with the accumulated light of trillions of aging stars. And consider this final rhythm. The rotation of galaxies themselves creates a kind of cosmic clock. Each time our Sun completes an orbit around the Milky Way, every 225 million years, we can mark off one galactic year. By this measure, the Sun is about 20 galactic years old, having completed 20 orbits since its birth. Complex life on Earth has existed for perhaps 2 or 3 galactic years. The dinosaurs lived and died within a single galactic year. Human civilization represents the tiniest fraction of one galactic rotation, a whisper in the cosmic chronicle. And yet the galaxy turns on, patient and indifferent to the dramas playing out on its dust motes, its rhythm continuing as it has for 60 galactic years, over 13 billion of our years, and will continue for countless galactic years to come. Align yourself with these deep rhythms, let go of hurried time, sink into the slow pulse of the cosmos, breathing with galaxies, turning with stars, eternal and at peace. As you rest now in the deepest regions of tranquility, your mind vast and empty as intergalactic space, your body barely a memory, let's contemplate the structures that galaxies create, the magnificent architecture they build from nothing but gravity, gas, and time. Spiral galaxies, like our Milky Way, construct the most elegant patterns in the universe. Their arms are not solid structures but density waves, regions where stars and gas temporarily concentrate as they orbit, creating bright lanes of star formation that persist even as individual stars drift through them. Imagine a traffic jam on a circular highway where the jam itself stays in place while cars pass through it, slowing briefly before accelerating back to normal speed. This is how spiral arms work. They're patterns in the flow of stars, not fixed objects but mathematical curves described by the interplay of gravity and rotation. These curves have existed for billions of years, maintaining their shape even as every single star has passed through them countless times. Some spiral galaxies are barred spirals, possessing a straight bar of stars across their centers with spiral arms emerging from the bar's ends. Our Milky Way is such a galaxy. Its central bar is about 27,000 light-years long, composed of older stars in elongated orbits that maintain this linear structure through their collective motion. The bar rotates more slowly than the disk around it, like the slow hand of a cosmic clock turning against a faster-moving background. This bar helps funnel gas from the outer galaxy toward the center, feeding star formation in the nuclear regions, acting as a cosmic conveyor belt operating over hundreds of millions of years. Ring galaxies represent some of the most unusual structures, galaxies with bright rings of stars surrounding relatively empty centers. Many ring galaxies form when a smaller galaxy passes directly through the center of a larger disk galaxy, like a stone dropped in a pond creating expanding ripples. The collision sends a density wave propagating outward through the disk, and where this wave compresses gas clouds, new stars form, creating a ring that expands at a stately pace of a few hundred kilometers per second. These rings can persist for hundreds of millions of years, slowly dissipating as they expand and fade, temporary sculptures carved by gravitational choreography. At the largest scales, galaxies organize themselves into sheets and filaments, creating the cosmic web we've mentioned before. These structures formed in the early universe as matter flowed along the gravitational contours created by dark matter, following the path of least resistance toward regions of higher density. The result is a universe that, when mapped on the largest scales, looks almost biological, like neural networks or root systems or the intricate branching of blood vessels. This structure emerged naturally from simple physical laws operating over billions of years, proof that the universe tends toward patterns, toward organization, toward creating beauty from chaos through nothing but time and gravity's patient influence. Within this cosmic web, galaxy clusters represent the nodes, the densest concentrations where hundreds or thousands of galaxies gather. These clusters can span tens of millions of light-years and contain more mass than 1,000,000 billion suns. And yet, despite containing so many galaxies, clusters are still mostly empty space. If you could shrink the sun to the size of a grain of sand, the nearest star would be several kilometers away. Even in galaxy clusters, where galaxies are packed more densely than anywhere else in the universe, the typical separation between galaxies is still millions of light-years. Space insists on its dominance, its fundamental spaciousness, even in the universe's most crowded neighborhoods. Some galaxies defy easy classification, their structures too peculiar or irregular to fit standard categories. These are often galaxies in transition, merging systems caught between their previous separate identities and their eventual unified form, or galaxies disrupted by tidal interactions, or small irregular galaxies that never quite settled into organized rotation. These peculiar galaxies remind us that categories are human constructions, that the universe contains more variety than our taxonomies can capture, that there will always be exceptions, outliers, beautiful anomalies that resist our attempts to organize them into neat boxes. Rest in this cosmic architecture, these patterns built by gravity and time, structures that need no architect, no blueprint, emerging naturally from the simple laws that govern matter and space, and know that you, too, are such a structure, complex patterns emerging from simple rules, beauty arising from physics. As you drift in the borderlands of consciousness, your thoughts scattered like stars across an infinite sky, your sense of self dissolving into the gentle darkness, let's journey to the farthest reaches we can observe, to those distant galaxies that exist at the very edge of visibility, their light so ancient it carries messages from the dawn of time. The most distant galaxies we can see are so far away that we observe them as they existed more than 13 billion years ago, when the universe was less than 1 billion years old, a cosmic infant compared to its current age of 13.8 billion years. These early galaxies appear small and irregular, still forming their first generations of stars, not yet settled into the elegant spiral and elliptical shapes we see in mature galaxies. They show us what our own Milky Way might have looked like in its youth, turbulent, actively creating itself, finding its form through trial and error across hundreds of millions of years. Their light has traveled so long to reach us that the universe has expanded significantly during the journey, stretching that light toward the red end of the spectrum until these galaxies glow in deep crimson and infrared wavelengths invisible to human eyes. Because of the finite speed of light, looking at distant galaxies is equivalent to looking backward in time. The farther we look, the younger the universe appears. At a certain distance, we reach the epoch when the first galaxies were forming, emerging from the dark ages that followed the Big Bang. Beyond that lies only the cosmic microwave background, the afterglow of the Big Bang itself, light that has been traveling for 13.8 billion years, coming from everywhere at once, surrounding us in all directions. This is as far as we can see, a horizon defined not by space but by time itself. Beyond this horizon, the universe continues, but its light hasn't had time to reach us yet. There exist galaxies out there whose light is still en route, traveling through the expanding darkness, heading toward us but still billions of years away from arrival. Some of the most distant galaxies are magnified by gravitational lensing, their light bent and amplified by massive galaxy clusters that happen to lie between them and us. Without these cosmic telescopes, these distant galaxies would be too faint to detect. The universe cooperates in revealing its own history, using gravity to help us see farther than we otherwise could. The lensed images of distant galaxies often appear stretched into arcs or even complete rings called Einstein rings, wrapping around the lensing cluster in graceful curves, distant galaxies transformed into cosmic parentheses embracing the nearer galaxies that magnify them. There is something profoundly humbling about knowing that the light from these distant galaxies left its source when the universe was fundamentally different, smaller, denser, hotter, wilder. The atoms in your body didn't exist yet, they were still hydrogen and helium floating in intergalactic space, waiting to be gathered into stars where they'd be forged into heavier elements. Earth didn't exist. The sun didn't exist. The Milky Way as we know it didn't exist. And yet that light traveled faithfully through all the intervening eons, through the formation and death of countless generations of stars, through the assembly of galaxies and the formation of the cosmic web, never wavering, never stopping, until finally arriving here, now, where it can be captured by telescopes and decoded by minds trying to understand the universe's story. The expansion of space means that the most distant galaxies we can see are currently much farther away than the light travel distance suggests. A galaxy whose light took 13 billion years to reach us is now actually about 46 billion light-years away, having been carried away by expanding space during the time its light was traveling toward us. This creates a strange paradox. We can observe galaxies that have moved beyond what's called our cosmic event horizon, the boundary beyond which, due to the accelerating expansion of the universe, light will never reach us. We see these galaxies as they were in the distant past, but we will never see what they look like today, and they will never see what we look like today. We exist to each other only as ancient history, frozen images from a universe that no longer exists in that form. And yet, despite these immense distances, these unbridgeable separations, the galaxies we observe in the distant universe obey the same laws of physics as nearby galaxies, emit the same spectral lines, form stars through the same processes. The universe is the same everywhere, consistent across all of space and time, reliable in its fundamental nature. This consistency allows us to understand distant galaxies even though we can never visit them, never touch them, never receive any signal sent from their current state. Let yourself sink into this profound distance, this unbridgeable vastness, knowing that separation is not isolation, that distance is not disconnection. We see them, they exist, the light reaches us, and that is enough. As you rest in this place, beyond thought, beyond even the awareness of resting, let's turn inward to discover the stillness that exists within galaxies' motion, the quiet centers around which all the cosmic dance revolves. At the precise center of our Milky Way, beneath all the orbiting stars, beyond the bright nuclear cluster, past the innermost rings of gas and dust, there sits a point of absolute stillness, Sagittarius A*, the supermassive black hole at our galaxy's heart. This black hole doesn't orbit anything. It defines the center. Everything else in the galaxy moves relative to it, but it simply is. 4,000,000 times the mass of the Sun, yet occupying a space smaller than Mercury's orbit, it anchors our galaxy through nothing but its immense gravitational presence. Around it, stars orbit at tremendous speeds, some completing their orbits in just over a decade, but the black hole itself remains motionless at the exact center of all this frenetic activity, like the quiet eye of a hurricane. This central stillness exists in every galaxy with a supermassive black hole. In the largest galaxies, these black holes can be billions of times the Sun's mass, yet they occupy relatively tiny volumes and sit perfectly centered, unmoved by the vast stellar populations wheeling around them. They are the still points in the turning cosmos, the foundations upon which galactic architecture rests. There's something almost meditative about their existence, massive beyond comprehension, yet perfectly passive, affecting everything through their mere presence without themselves being affected, existing in a state of profound equilibrium with the universe around them. Within the motion of galaxies, there also exist what astronomers call Lagrange points, special locations where the gravitational forces from different masses perfectly balance, creating islands of stability in the gravitational landscape. In these points, smaller objects can maintain their positions relative to larger ones without expending energy, held in place by the precise equilibrium of competing forces. Though we typically discuss Lagrange points in the context of two-body systems like the Earth and Moon, similar principles operate on galactic scales, creating stable orbits and configurations that persist for billions of years. Nature seeks these equilibrium points, these places where forces balance and nothing needs to change. Consider also the concept of the corotation radius in a spiral galaxy, the distance from the center where the spiral pattern rotates at the same speed as the stars themselves orbit. Stars inside this radius orbit faster than the spiral pattern, passing through the arms from behind and emerging ahead. Stars outside this radius orbit more slowly, approaching the arms from ahead and falling behind after passing through. But right at the co-rotation radius, stars in the spiral pattern move in perfect synchrony. A star at this special distance would maintain its position within a spiral arm indefinitely, neither advancing nor falling back, existing in perfect harmony with the galactic structure. Our Sun is near, though not precisely at, this co-rotation radius, meaning we spend long periods within spiral arms but slowly drift through them over tens of millions of years. In the outer regions of galaxies, where stars are sparse and the gravitational influence of the central regions weakens, orbital velocities become slower, more languid. Stars here take hundreds of millions of years to complete a single orbit, if they're bound to the galaxy at all. Some stars in these distant halos might be barely gravitationally bound, moving so slowly that a small perturbation could send them drifting into intergalactic space. They exist in a twilight zone between belonging and leaving, between connection and independence, held by the thinnest gravitational threads to the galaxy that birthed them. There exist also, in certain galaxies, stable nuclear rings, circular structures of star formation that persist for hundreds of millions of years, fed by gas flowing inward along the galaxy's bar and accumulating at a specific radius where orbital dynamics create a stable configuration. These rings rotate as solid structures, maintaining their circular shape and their star-forming activity, cosmic whirlpools that have found their natural level and maintain it through the self-regulating balance of gravity, rotation, and gas dynamics. Feel the stillness at your own center, the quiet point around which thoughts and sensations revolve. You are like the galaxy's heart, motionless within motion, peaceful within change, the still observer of all that passes. Rest there, in that unchanging center. As you float now in the deepest peace, barely existing at all, just awareness itself resting in infinite space, let us complete our journey by contemplating the ultimate destiny of galaxies, their far future, billions upon billions of years from now, when the universe will be so different from today that almost nothing we know will remain the same, and yet the galaxies will endure, transformed but present, continuing their ancient journey into an unimaginable tomorrow. In about 4 billion years, the Milky Way and Andromeda will complete their slow approach and begin to merge. Their first passage through each other will be gentle, stars passing between stars with room to spare, like two flocks of birds flying through one another without collision. Then gravity will draw them back together for a second pass, and a third, each passage further entangling their stars in gas, until finally, perhaps 1 billion years after the first encounter, they will settle into a single, larger elliptical galaxy. This new galaxy, sometimes called Melkometa, will contain all the stars of both galaxies, rearranged into new orbits, new patterns, a synthesis of two ancient structures creating something that has never existed before. And through it all, most stars will never come close to collision. Planetary systems will survive. Life, if it still exists then, will witness the night sky gradually filling with the approaching stars of Andromeda, growing brighter year by year, until the two galaxies interpenetrate and the sky blazes with the combined light of 1 trillion suns. Far in the future, trillions of years from now, the expansion of the universe will have carried distant galaxy clusters so far away that their light will no longer be able to reach us. The observable universe will shrink, not because light is disappearing, but because space is expanding faster than light can cross it. Eventually, inhabitants of the Melkometa galaxy would look out into a night sky containing only their own merged local group of galaxies, with everything else receded beyond the cosmic horizon. They would live in an island universe, surrounded by darkness, with no evidence that other galaxies exist anywhere. The universe will have become lonelier, quieter, more intimate in scale. As the eons pass, galaxies will gradually exhaust their gas supplies, converting the last hydrogen and helium into stars, until finally no new stars can form. The galaxies will darken, populated only by the longest-lived stars, small red dwarfs that can burn for trillions of years on their meager fuel. One by one, even these will fade, until galaxies contain only stellar remnants, white dwarfs, neutron stars, black holes. The galaxies will still be there, still rotating, but they will be invisible, dark structures defined only by gravity, holding their dead stars in eternal orbits through an ancient, cooling universe. Even these dark galaxies won't last forever. Over timescales so vast they dwarf even the current age of the universe, 10 to the 100th power years, a 1 followed by 100 zeros, the stars and galaxies will gradually be ejected through gravitational interactions, or will spiral inward and be consumed by the central black hole. The galaxies will slowly evaporate, dispersing their stellar remnants into intergalactic space. And eventually, even the black holes will evaporate through Hawking radiation, taking unimaginable eons to slowly dissolve into space, particle by particle, until nothing remains but the faintest whisper of energy scattered across an incomprehensibly vast, cold, dark universe. But even in this far future, in this seeming end, there is something beautiful. The universe will have achieved perfect equilibrium, perfect entropy, perfect peace. No more struggle, no more change, no more becoming, just being, pure and simple, existence without striving. Every particle will be maximally separated from every other particle, all energy evenly distributed, everything in its final, most stable state. It's not death but completion, the universe having played out every possibility, explored every configuration, and finally settling into its ultimate rest. And yet, who knows what lies beyond even this? Physics breaks down at the extremes of time and space. Perhaps the universe is cyclical, perhaps there are other universes, perhaps in timescales we cannot even conceptualize, something new emerges from the silence. The galaxies teach us that endings and beginnings are often indistinguishable, that death and birth are two faces of the same transformation, that nothing is ever truly lost, only changed, rearranged, returned to the cosmic whole from which it came. And so we return to where we began, floating in the quiet darkness, held by forces we cannot see, part of a story so vast it encompasses all of time and space. The galaxies turn above you, patient and eternal. They were there before you began, they will be there after you end, and in this moment, you and they are one, awareness gazing at awareness, the universe knowing itself through your quiet observation. Rest now, completely, deeply, knowing you are home, you have always been home, held in the gentle arms of the cosmos, safe in the vast, patient, loving darkness between the stars.